Hello.
Hello.
Okay, so let me know how many of you are here. Please comment. Let me erase this. Okay. And everything is visible, audible or not, please tell me. I mean, visible. Let me write something. Hello, audible, visible, everything is clear or not, please let me know. Yes, sir, okay. Visible, audible, clear, sound is clear, and everything else is clear. Okay, then. So I think around what is the number of you? 14 is watching. Okay, let me increase around 25, then I will start. Okay, so please inform if anyone is there. So now, around 20. Let me write. Three only. Okay, so if anyone comes, that's good. Otherwise, let's start, huh? Okay. So only I can see the comments, and you can ask me doubt or anything else in comments only. So how are you and how are you doing? I think okay. So coronavirus is going on, so stay at home, first of all, and be safe. Okay. Uh, Newton laws of motion, but one second. Okay, I'm sorry. So I think the basic laws, first law, second law, third law, but still let me analyze it. Just let me give small time and discussing these laws. So first law tells us that inertia law of inertia, if a body is in rest, it will remain on rest. If a body is in a state of motion, it will remain on its state of motion until and unless external agent acts on it. Second law, F is equal to ma. Third law, action has equal and opposite reaction. So let me discuss by examples only. So here I have an object of mass m. Let me give three forces. The mass is, let's say, 2 kg, and let me apply one force of 10 Newton, other force of 20 Newton, and here is another force of, let's say, 40 root 2 Newton, and this angle is 45 degree. And how to find the acceleration? Process is same in Newton's law in all the problems. First, draw the free body diagram, And after drawing free body diagram, use F is equal to ma. If there is any constant equation, that I will discuss after some time, if there is any constant equation, write the constant equation F is equal to ma and constant equation all together, solve it, and you will definitely get your answer. So how to solve this? Now let me take two direction x and y. Let me reserve all the force along x and y direction. So 10 and 20 are already along x and y direction. 40 root 2, 40 root 2, cos 45, 40 and 40. So now along x direction, net force is 40 and 10. So net force along x direction is 50. I will write f of x is equal to m times ax. That means 50 is equal to mass is 2 into acceleration is 40 plus mass is 2 and acceleration I don't know. So acceleration is 25 meter per second square. Similarly, along y direction, you can do it. Fy is equal to m times ay. Fy is 60. Mass is 2 ay. So ay you got 30 meter per second square. So final acceleration, one is 25 meter per second square, other one is 30 meter per second square. So net acceleration you can write 25 I cap plus 30 j cap, and magnitude is ax square plus ay square root over, and if you want to find theta also you can find tan theta is equal to a y by a x. Okay, this is the basics. These are the basic thing in Newton's laws of motion. Okay, everyone is here now, getting it. So now, so this is the basic thing. Let me give you another problem. So which marker is working? This is not working. This one is working. Okay. So let's say I have two different objects, 10 and 5 Newton. Let me apply some force of 30 Newton. And I am asking you right now, what is the normal force acting on 5 kg due to 10 kg, or normal force acting on 10 kg due to 5 kg? So in Newton's laws of motion, few things you have to follow. First, what is a system? Note down the points. First point, you have to find the system. Second, after finding out system, draw the free body diagram. F is equal to ma, write down from this free body diagram. And fifth one is solve this equation. Solve equation. All must have same acceleration, both magnitude as well as direction. Otherwise, you cannot take ABC as a system. So if A has acceleration along this direction, B has along this direction, C is along this direction, and this is same magnitude, direction I show. Now you can take AB as a system, but you cannot take BC as a system. You can take A alone as also a system. You can take B alone also a system. You can take C alone also a system, but you cannot take BC or ABC as a system. You can take AB as a system. Please remember this. I will use this thing again and again. Okay? So now, here it is clear that I can take 10 and 5 as a system because they will move right side with the same acceleration. So then, okay, I will tell one thing later. So everyone is here, right? Sir, can you please write on right side of the board only? Right side. This side is not visible. This is right side. Okay, that's fine. I will try to do that. Uh, right. So now I took 10 and 5 kg as a system. So acceleration is F is equal to ma. So net force is 30 is equal to mass of the system is 15 into A. So A is equal to 2 meter per second square. That's fine. We got the acceleration. But question was how to find normal force. Now take 5 kg as a system, and what are the forces acting on 5 kg mass? This is the normal force acting on 5 kg due to 10 kg. And another force acting on 10 kg due to 5 kg. You will say that, sir, why you didn't take normal force here when I am considering 10 and 5 as a system? Because these are internal forces. And when you will apply to a system, then you will write F external force is equal to mass into acceleration of the system. And in this system, external force is 30 kg. But when I take 5 kg as a system, then external normal force is external force for 5 kg. Okay, mg and NBS is also acting, but why I am only considering x direction. So along x horizontal direction, only this normal force is acting on 5 kg due to 10 kg. And I know acceleration along x direction is 2 meter per second square. So let me write net force is equal to m into a. So normal force is 10 Newton acting on it. If I now consider 10 kg also, in 10 kg 30 is acting, normal force m is acting. Let me write n dash, and it is moving along with acceleration a. So 30 minus n dash is equal to 10 into 2, 20. So n dash must be is equal to 30 minus 20 is 10. So n dash and n both have same magnitude but opposite direction. This is Newton's third law. So one is action and other one is reaction. Right? So Newton's third law you can say proved from here. Action and reaction pair. Okay. So I will give you one more question, but if you have any doubt in this basic, first let me know. Comment please if if there is problem in the basic. Everything is okay, then you can type yes, everything is cool. Then I will give you one more problem. Okay then. Okay. So let me give you one more example for you guys. I will not solve. So one, two, four. Let me give you 3. Here a force is acting 60 Newton, and here is force is acting 30 Newton. Now I am asking you, find all the normal forces acting on 2 kg block. Write down in comment 2 kg block. So all the normal forces acting on 2 kg block. Write down on comment. is the ink? Everyone has to write down the solution. Huh? This one is missing. So, no, do you have pen and paper with you right now? If you don't have, please bring pen and paper and sit. Okay, then let me solve if you are not doing. Okay, so let me take this 60 minus 30 net force direction is equal to m total mass of the system is 6 kg into A. So A is equal to 60 minus 30 T by 6. That means 30 by 6 is. So I think, sorry, video was fast. I don't know why for some time. Okay. So 1, 2 and 3 kg net external force is, one is 60 and other one is 30. So 60 minus 30 is equal to net mass 6 into A. So acceleration is 5. Now let me take 3 kg as a system. Now if I take 3 kg as a system, forces are, one is 30 and other one is, I don't know, let's say some N1 normal force is acting on 3 kg due to 2 kg. So acceleration is, A is 5. So N1 minus 30 is equal to 3 mass into acceleration is 5. So N1 is equal to 15 plus 30, 45. Now let me take 2 kg as a system here. If I take 2 kg as a system, one force acting here N1 due to 3 kg, and let me say N2 due to 3 kg, and acceleration is n. So let me write N2 minus N1 is equal to 2 times acceleration is 5. So 10. But N1 I already know 45. So let me write N2 minus 45, and similarly N2 you got it 55. How many of you answered it? No one. How? So do you have pen and paper? We got this same answer. Okay, but you comment it. Okay. Otherwise, I cannot interact now. How will I know you are getting it or not? And please bring pen and paper, everyone. Okay. So now, next, I asked you what are all the normal forces, but this is not all, because in exam you may forget this is also another normal force acting on it, and yes, that is 2z, and other one is n1 and n2. So total three normal forces acting, one is n1, n2 and s is equal to 2z, that is 20. Okay, now let me go into another topic. So this type of example is, I think, okay. Do you want one more example for this kind, or I will go further? Please comment. Yeah, now comment it that you want this type of example, one more example of this kind, or I will go further. Go further. One comment only I got. Okay, okay then. So now let me continue and I will go further. Pulley system I will discuss now. So you have a pulley here, and you know this is, so I am teaching you like a revision class. Everyone whoever watching, this is like a revision class. I am not teaching you in details. Then another is M2. This is your pulley. So what are the forces acting on it? You know, M1G tension T1, M2Z tension T2, and acceleration, let it be A. So you will write M1G minus T1 is equal to M1A, and then for this body you will write T2 minus M2Z is equal to M2A. Solve this to T1 is equal to T2 because same string, that's why same string, and the string has mass 0, that's why I took T1 is equal to T2. If it is not same string, tension will different. If it is a massive string, then tension will differ. I will give you example for that also. Now you solve it and you will get A is equal to M1 minus M2Z by M1 plus M2, and tension you will get 2 M1 M2 by M1 plus M2 into G. Now I will give you one shortcut how to solve this thing. So shortcut is like this. You have to find shortcut. Let me write acceleration is equal to net pulling force by net mass. Net pulling force. So here pulling force is M1G and this side pulling force is M2Z. So here M1G, one pulling and other one is M2Z. So net pulling force becomes M1G minus M2Z by M1 plus M2. Then they ask you tension. Then you take M1 as free body diagram and draw the free body diagram for M1 and write M1G minus T is equal to M1A like this, and then you can get the value of tension also. This shortcut is applicable for only simple pulley type problem. Okay? Okay. Simple pulley type problem. So let me give you one more example. Yeah, here let me give you. Find acceleration for this object. This is M1, this is M2. Okay. Now for this figure, what is the acceleration? First you did it, then I will solve. So net pulling force by net mass. What are net pulling force? You don't have to solve. Only after looking at this you can get it. Pulling force is M2Z. No one is pulling this side. No one is pulling this side. So pulling force is M2Z and mass and total mass is m1 plus m2. So this is the answer. Let me give you one more example. Let me erase this. Now m1, m2, m3. Solve it. What is the acceleration? You solve it, huh? What is the net pulling force? Yes. Net pulling force. One is m1g, other one is m3g. That's all. No other pulling force. So your answer is m1g minus m3g by total mass is m1 plus m2 plus m3. This is the acceleration. If I give you, okay, let me not complicate this thing. If I complicate this thing, okay, right now it's okay. Now, one more question. Let me give you. M1, you do it and question M1 M and find out the acceleration. Okay, just tell me that internet connection is okay or not. Means sometime I am seeing that here live streaming is, I mean, there is a problem I think in the live streaming. So you just tell me everything is right or not. Internet connection, and have you solved the question? Please comment. No, sir, it is not that clear. Oh. So what will I do? Let me decrease the pixel. Now 720 pixel I have. So 720 pixel I did. So let me, this is the first time. Next time whatever I will do, I will decrease the pixel and I will do it. Then it will be clear. Okay. What is that? No, sir, it is not. No, sir, it is not clear. No problem. Next time I will do it. So, what will I do? Here, I will end it otherwise, and I will do it again tomorrow. Tomorrow again I will do it. Newton laws of motion only. From this I will continue. I will end it here. Is it fine? Please comment. So no problem. Tomorrow I'll decrease the pixel size. It will be clearer. Okay. Uh, so here I will end otherwise, and tomorrow again I will start Newton laws of motion. Please write. Signal is not all clear. Okay, sure. Okay. So then okay. So I will end here and I will start again tomorrow with the same thing. I will continue and. Be safe and don't waste your time much. Okay, sometime you can watch TV, sometime you can do whatever, but otherwise you do. Okay, then thank you. Tomorrow we will meet. If any other students are also interested, you tell them, and thank you. Bye bye. Tomorrow I will give you the time.